I have your science recap video for April 26th and 27th. We took our chemistry unit test today. Make sure that when you do take that you open up and you have a periodic table in front of you to help you answer those questions. After our unit test, though, we started our STAR review. You have 8th grade science STAR on Thursday, May 6th, and including today, we'll have 4 days of STAR review. The first thing you need to do is print off this packet. If you're not able to print or you'd rather have your parents just pick up a copy, we have lots in the front office already for you to grab, but you absolutely need a physical copy of it, not digital. It's kind of long, so you might want to just have a parent swing by and pick it up. We're going to be using this packet every class between now and May 6th. It's chunked, it's broken up into 4 different days. As you're working on it, you're also going to be using the STAR review page linked in our Canvas agenda. You'll see that this has several buttons that are linked to various resources that you're going to need to use in order to prepare for the STAR test and complete that packet. Your virtual science notebook is linked, and then the different topics or categories that are going to show up on that STAR test are also linked. And if you read the label underneath, it'll tell you what day you need which one. So today is day 1 of our 4-day STAR review. So for day 1, we're going to be clicking on this physics link. And you're going to click on that to go through a quick presentation to remind you of what we've learned this year. There's also beneath that button the unit overview pages with learning targets and Quizlets if you're kind of stuck and wanted to refresh your memory. Today, we're going to make sure that we get everything for the day 1 portion done, which means all the way up to question number 21. It's a review of some 6th grade topics like potential and kinetic energy, energy transformations, and then the beginning of this year we learned about balanced and unbalanced forces. There's a really good brain pop if you click on brain pop on the left-hand sidebar and type in forms of energy. That's worth watching as well. In the STAR review packet, we're going to go through and look at that together. It's really important that you have this and you have this complete. You will use this on your final exam. So if you do it, you will be able to use it on your exam. And it is, like I said, chunked by days. So let's go through the day 1 stuff. And what we're doing in class, and our expectation is for remote learners as well, is if the teacher writes it, you need to be writing it. So we started off with potential and kinetic energy, and as you go through the presentation that's linked from that page in Canvas, there's a short video to watch and different kind of little notes to look at. But we talked about comparing and contrasting potential and kinetic energy. Potential energy is stored energy. Kinetic energy is the energy of motion. In the middle, our intersection, energy just means the ability to do work. And we should be able to give examples of either potential or kinetic energy, like chemical energy stored in food or a battery, gravitational potential energy, an object from its position, like a ball at the top of a cliff. Energy of motion is anything moving, so that ball falling down the cliff, or a mechanical energy like this person running. We went through and discussed practice questions and added notes and underlined key parts, which you should be doing as well. Here, if we're looking at how to describe the energy change as the person lifts the mallet and then lets it fall down towards the target, what we need to focus on is at the top, there's a lot of potential energy because it has height. As the mallet goes down, the mallet loses its potential energy, but it gains kinetic energy as it's moving faster and faster. And so D is the best answer choice. The potential energy is converted or changed to kinetic energy. Number 3 is again a conversion question. We start with a bicyclist at the top of a hill, and there's 4 points. We should recognize at the top of the hill there's 0 kinetic energy if they're not moving. Because of their height, there's a lot of potential energy. As the bicyclist goes down the hill and loses height, they're losing their potential energy, but they're going faster. They're gaining kinetic energy. So at what point is the kinetic energy closest to 0? At the top of the hill, when they're either not moving or going the slowest, they have the least amount of kinetic energy. In a pendulum, a point can be attached to a pivot or a fulcrum and released, and at the top it has potential energy. But what happens to that potential energy as it moves and reaches point P? You can't create or destroy energy. It's just like matter, but it can transform or change. And so the potential energy changes into the energy of motion or kinetic energy. If we have a cart at the top of a hill, what best describes the energy of that cart just as it gets to the bottom? As it's getting closer to the bottom, it's going faster and faster and faster and faster. So right at the bottom here, just before it reaches the bottom, it is going the fastest, which means it has the most amount of kinetic energy. We also reviewed just general types of energy and energy transformations, which means to change from one type of energy to another, because again, you can't create or destroy energy. So some common ones that you'll see are chemical, whether it's in our food or in a battery. You'll see light or radiant, like a light or a flashlight or the sun. Anything that's plugged in, that's electrical energy. Heat or thermal energy. And so we really just practice describing, looking at how does it start and how does it end. And then we use that to answer the next set of practice questions. The first question is asking us, what happens, what energy transformation, what change in energy must happen for the car to go from X to Y? You have to start with some energy that's stored in the gas tank, and it changes to energy of movement. That kinetic energy is also called mechanical energy. If you're playing a video game, if a handheld Switch or whatever, the game is powered by batteries, but I'm sure you've noticed after a while they heat up. That game system gets hot. And so what's best describing that? Energy from the batteries is changed or transformed into thermal or heat energy. How do toasters work? Again, it's another energy transformation. We should notice that it starts with electrical energy and then it changes to other forms. What other form toasted the bread? It got hot. That's heat or thermal energy. Number 10, if we look at a hot plate, what type of energy transfer occurs when a beaker of water is heated on a hot plate? So the key words are, we see rather in the picture that it's plugged in. That's electrical. And then heated, hot plate, that's thermal energy. So the electrical energy goes through the plug and then transforms to heat or thermal energy. In the windmill question, it's important really just to study the diagram and look at the wind turbine. The wind energy will turn the blades of the turbine. Those rotating blades then turn a rotor that's inside this generator, part of the motor itself or the engine. The energy moves then from the generator into the power lines. It moves through the power lines and then it goes to our house and can do things like heat our toast or create thermal energy. Between which two steps is mechanical energy? So think machine, moving parts, be converted to electrical energy. We have moving parts in 2, and then we have energy leaving electricity in 3. So between 2 and 3, we have that energy transformation. We also reviewed balanced and unbalanced forces. A force in general, remember, is a push or a pull. If you have a change in motion, whether it makes something speed up, slow down, or change direction, it was an unbalanced force. If there is no change in motion, so either the object is at rest or it might be going at a constant speed in the same direction, there are balanced forces acting on the object. We also reviewed how to find the net or total force if there's more than one force acting on a single object. If they're going in the same direction, they're working together and we add them. If there's multiple forces going opposite directions, they're counteracting each other and we would subtract them to get the total force. So then we practiced. So we need to really focus on what is the question looking for. And if I read through, this is asking me, when is the sled experiencing unbalanced forces? So what does that mean? It means it's changing its motion. So if it's going along this frictionless track, it's going to go at a constant speed in a flat area. But in section 2 and 4, it's either going to gain speed as it goes downhill or slow down as it goes uphill. So it's changing its motion in 2 and 4. Whenever you have a change in motion, that is an unbalanced force. And we see the same thing in the next question. Why does the leaf fall in a crooked path rather than straight down? Why is it changing its motion? We need to really key in on that change in motion. We're going to look for an answer choice. Air currents and gravity applied changing and unbalanced forces to the leaf. Same thing in number 17. If we're dropping a marble into a graduated cylinder and steadying its motion, when did the marble experience unbalanced forces? When did it change its motion? Well, over here, if I look at the description, it changes its motion when it's increasing or decreasing its speed. So parts 1 and 2, if the speed is constant, it's not changing its motion. Same thing, I'm seeing a theme here. What causes a sudden movement in tectonic plates? In other words, why do we have a change in motion? Unbalanced forces. Number 19, how do we calculate net force? If the student is pushing a board towards one student and there is friction resisting that, we need to remember that friction is the force that goes opposite motion. And so if friction is going in the opposite direction, we would subtract those to get the net force of 6 newtons. In number 20, we're given a chart and a diagram of a cart going down a hill. And as I really take some time to study the chart, and I always do this before I even really look at the question, I analyze the data. At the 4 different locations, I'm given the average speed of the cart. And I notice that the average speed is increasing. It's going faster and faster and faster as it goes down the hill. So I began to think and just brainstorm, what do I know about that? I know that means there's a change in motion. So if I know there's a change in motion, which there must be because the speed is increasing, that means that I probably am going to look for an answer choice that has the word unbalanced in it, because I know that unbalanced forces change motion. As I read which best explains the student's data, as I read through there, the best answer choice by far is the speed of the cart is increasing. Yes, I agree. As the cart goes down the ramp, because the force is acting on the car unbalanced. And finally, our last day 1 question is we're looking at 6 different situations and asked which object in the list experienced unbalanced forces. So again, changing motion. I would eliminate the first answer choice if you're going at a constant speed and across a table, so it's not going up or down, but just horizontally, those forces are balanced. If the ball's just sitting there, not moving, balanced. Going down a ramp. I just know from experience as I go down, my speed's increasing, but also I'm changing my direction. Back and forth. Again, boop, boop, changing direction. Both of those are unbalanced. Constant speed. Well, that's balanced. Landing on a branch. So again, I'm changing direction. I'm also slowing down as I land on that branch. So using my skills in labeling, I can identify the things that have a change in motion, which lead me to see that the can, the swing, and the bird are all experiencing unbalanced forces. Our expectation is you went through and completed and checked your answers for questions 1 through 21 on this packet. We will continue with our STAR review next class. Let your teacher know if you have any questions.